Starting from the Windows 7 version, BitLocker allows encryption not only of the BASIC and the system disks, but also of USB disks. This solution is also called BitLocker to Go. The general mechanism is exactly the same, but does not require the TPM module. In this case, the TPM module is optional. We can encrypt USB disks, and the key that was encrypted will be protected by a password and not stored on the TPM module. This solution is relatively efficient. We can encrypt a flash drive with a few gigabytes in about half an hour. It takes about the same amount of time to decrypt it. The use of such a flash drive means the reduction in efficiency of about 5%, such as we mentioned earlier. The initial encryption of the entire area is quite time-consuming, but it can be cancelled at any time. Interestingly, we can connect the flash drive encrypted in this way to earlier versions of Windows. A program code will be written on the flash drive, allowing its decryption. Hence the name BitLocker to Go. The attached program permits reading encrypted data, but does not allow their modification. Such a flash drive only becomes a carrier for reading all computers with the exception of those with the relevant edition of Windows 7. In conclusion, we compare BitLocker to TrueCrypt. These are solutions with similar functionality. Both systems allow encryption of entire disks. This functionality is based on the fact that operating systems are not linked directly to a disk. We have a hierarchical structure of layers, and between these layers we can place additional programs, such as drive encryption programs. This may be a layer between the physical disk and a partition, or between a partition and a folder. BitLocker is an original solution of Microsoft, and TrueCrypt comes from the TrueCrypt Foundation. BitLocker is a little newer, but it's commercial. It's available only on selected versions of Windows Vista and later. It does not allow hiding disks. It does, however, allow authenticating the user by using a password, key, TPM module, or any of their combinations. In TrueCrypt, we only have a password or a key. For the same reason, BitLocker supports checking the integrity of the computer, and TrueCrypt does not. BitLocker also allows for the generation of extra keys for administrative reasons. Neither of the two programs enable hardware-based encryption. Only TrueCrypt allows the encryption of a physical disk in the lower layer. BitLocker encrypts all partitions, but not all of the physical disks. Partitions can also be encrypted with TrueCrypt. Encryption of virtual disks is characteristic of TrueCrypt. As far as algorithms are concerned, in the case of BitLocker, AES has been chosen for us. In the case of TrueCrypt, we can also choose the algorithm ourselves. I'd recommend AES. An interesting thing is that we can encrypt the disk using several algorithms. We can encrypt data again a second time. In regards to mode encryption, in BitLocker we have CBC as well as in TrueCrypt, and I recommend selecting CBC. Elephant is an original solution in BitLocker to check the authenticity by diffusing bits. TrueCrypt partly verifies the authenticity by such that a change in one bit of plain text causes a change of more than one bit in the ciphertext. Knowing how BitLocker works, let's consider what we should not do, so that after disk encryption, the data saved on the disk would actually be secure.